All right, so we're looking at our identity sheet. We're looking at our new sum and difference formulas. And number 1 on our warm-up sheet, if we look at the pattern, it goes sine, cosine, cosine, sine. That is the pattern for a sine expansion, or in this case, we're going to condense it. So this is the formula for sine of a plus b, with a and b being actual numbers, so that's nice. So this really is the sine of 118 plus 62. Well, what is that? Isn't that 180? Hey, y'all, you know what the sine of 180 is.
1.
No.
0.
0. There we go. So on this warm-up sheet, they're first having you recognize which identity you're looking at, and then we're using it to create a simpler problem that we can use the unit circle to identify. So this would definitely be a don't touch your calculator moment if possible. The next problem here, number 2, it goes cosine, cosine, sine, sine, which is the pattern for the cosine formula. But cosine's weird because it has the opposite sign in the formula. So this is really the cosine of a minus b, which would condense down to 47 minus 17, better known as cosine of 30. And what is the cosine at 30? Square root of 3 over 2.
Gosh, dang it.
So, those are degree ones. And then there's tangent, which I don't have a cute little chant for because it really doesn't need it. Tangent, just like sine, keeps the same sign as the pattern that it starts with at least. So this one I can tell because there's a plus sign in the middle and there's a bunch of tangents is going to be tangent of a plus b. The way the formula works out for tangent of a plus b versus tangent of a minus b, they look really similar again. It's just a case of who has a positive sign and who has a negative sign in the formula. So this one would be the tangent of 12 plus 168, better known as the tangent of 180. All right, don't fail me now, guys. Tangent is sine over cosine, so at 180 degrees, your sine is a 0 and your cosine is a negative 1. What does that come out to? 0. Very good. So the tangent at that comes out to a 0. We're not. So this, if you look on your formula sheet, it says it equals tangent of a plus b. So this is an identity. If you have the tangent of something plus something, you could rewrite it like this. And you're probably asking yourself, why would I want to do that? And that comes up in our lesson next. And now if you have something that looks like this, you could rewrite it like that. And again, it's math dependent, right? Do I want to condense it or expand it? It depends on what I'm trying to do. We're going to see some questions in a moment where you want to expand them because it allows you to do some simplification. We're going to have some things that are not from the unit circle. Okay? So it gets a little crazy though once they start measuring in radians because my brain does not think about radians too well. For instance, number 9 here. Condensing isn't difficult. We'll just deal with the 5th grade fractions. But I notice the pattern, number 9, says sine, cosine, cosine, sine. That's the chant for the sine of a plus b. Thank you. So a and b, because you're adding, it doesn't really matter who you call who. You got to add pi over 9 plus pi over 18. All right, 5th grade, kick in with me. Common denominators. This is really a 2 pi over 18. So that would be 3 pi over 18. Y'all, what is 3 pi over 18? Yeah, so this is really asking you for the sine at pi over 6. Which is? Redeem yourself, child. Thank you. So your task right now on this worksheet was just simply recognition of like which pattern are we looking at? Which identity is this? And then being able to simplify it down as far as you can in this case. But now we're going to go look at our notes. And we're going to see what else we can find for a use on these identities. And the answer is a whole lot of things. So this is going to be a good time. There's actually quite a bit in this lesson, but it's all revolving around those 6 identities that are at the middle of your page there. Again, I'm not going to make you memorize them, but I will tell you right now as we go through our work and as we go through our homework, which you are totally doing your homework this time, guys, we're going to stop this song and dance. It is not cute when you don't practice. It is atrocious test scores is what it is, okay? Practice. You're doing your homework this weekend. Yeah, I called you out on the internet. You heard me. But you could have done better. Always could do better. All right. There's some questions that are already done for you for the sake of our time because we have so many things that we need to do. I'm not going to go through this one in great detail, but the question itself said find the cosine of the exact answer for the cosine of 375 degrees. So first of all, 375 degrees, if you wanted to coterminal that, that would be the same thing as cosine of 15. Guys, what's the problem with me asking you to look at your unit circle and find the cosine of 15? It's not a part of the unit circle. The unit circle is a very specific set of values. So, because it's not a portion of the unit circle, you would have to rewrite 375 as either a sum or a difference problem based on angles that you do know things about. So, they decided to go with 330 plus 45. Are those both angle measurements that you can see on your unit circle? Yeah. So then they split it up as the cosine of a plus b into cosine, cosine minus sine, sine. And every one of those functions was something they could pull off the unit circle. So the cosine of 330 is square root of 3 over 2. And the cosine at 45 is square root of 2 over 2. So then they multiplied them together and they got square root of 6 over 4. Similarly over here, sine at 330 is negative 1/2 straight off the unit circle. Sine at 45 is square root of 2 over 2. And when they multiply those together, negative negative became a plus square root of 2 over 4. And then in math, as long as you have common denominators, you can add fractions together. So this is their final answer. This is what we call an exact answer. If someone was to type cosine of 375 into their calculator in degree mode, they would get something very not exact, and your calculator does not have the capabilities to bring it back to that answer. So we have to use these sum and difference formulas in this case to actually evaluate a cosine function at a strange value. So this one's not done for you. So negative 15, well, that's not on my unit circle. Can we all agree we're going to need to use a subtraction problem? That would be the best way to do this. I heard 30 minus 45. Would that be the same thing as negative 15 degrees? That would work for me. All right, so here's what's going on. I'm going to call this A. I'm going to call this B, because that's how the pattern works. And the cosine formula from memory for me, and eventually for you guys, is cosine, cosine, sine, sine, with the opposite sign. So it's going to be cosine of A times the cosine of B plus opposite sign, sine, sine. So sine of A times sine of, sine of B. It's part of the formula. It's just 45. Good question. All right. So here's what I should be doing. I should be writing out exactly what I'm looking for. So cosine of A would be cosine of 30 degrees, right? Which we're going to visit the unit circle in a second. Cosine of B would be cosine of 45 degrees. Sine of A would be sine of 30. And then sine of B would be sine of 45. All right, y'all, it's time to visit your unit circle. What's the cosine of 30? Square root of 3 over 2. What's the cosine at 45? Square root of 2 over 2. Got a big plus sign in the middle of those two. All right, sine at 30 is a 1/2. And then this sine at 45 is square root of 2 over 2. So when I look at these multiplication questions, I smush those numerators together, and this becomes the square root of 6 over 4. This guy becomes square root of 2 over 4. And they do have common denominators, which means my exact perfect answer for us would be square root of 6 plus square root of 2, all of it over 4. And then I have a moment of deja vu, because I'm like, wasn't that the question previous to this answer? And then you're probably like, wait, are they all going to come out to that? And the answer is no. Let's investigate this a little further, guys. This original one that they already had done for you was technically the cosine of 15 degrees. What you guys just found for me was the cosine of negative 15 degrees. Aren't those twinsies angles? And cosine is positive in both of these quadrants. So it makes sense that we got the exact same answer because they are relatively the exact same question. Okay? Now, you're like, ooh, if I recognize that later on in my homework, can I just write down square root of 6 plus square root of 2 over 4? And the answer is no. You're going to show me the breakdown, the substitution, and all of it. All right, so tangent of 15. I just want you to know that my key for this looks very scribbly Because originally, like every good soul in the world, they were like 15. Easy. 45 minus 30, right? Obvious. Yeah. So then I forgot something really important that my trig teacher probably told me like 20 years prior. Tangent of 30 is like the worst possible thing to work with. What is the tangent of 30? So it's square root of 3 over 3. Like when you rationalize it. The tangent of 45 is like my favorite. That's 1. And the tangent of 60 is way less gross than this one. It just ends up being the square root of 3. So tangent of 60 is nice. Tangent of 45 is nice. Tangent of 30 is disgusting. So a good piece of advice is if you don't have to use 30 degrees in the tangent, you'll be much happier. So let me tell you, what we're about to do is be smart. We're not going to use 30 degrees to break this up. We're going to use 60 and 45. What would that look like then?
60
Yeah, 60 minus 45 would work. Now, if someone was like, no, I'm a rebel. I'm going to do 30 minus, or 45 minus 30. Cool. You're going to have a ton of rationalization work, and it's going to make your like hair fall out. It's awful. Don't do it. So just recognize that what we're about to do is actually the easy version. So here's your A, and here's your B. And the tangent formula starts off looking very similar. It's tangent of A minus tangent of B. So I'm going to write down the tangent of 60 minus the tangent of 45 over 1 plus, and then you multiply them together. Tangent of 60 times the tangent of 45. All right, now we go visit our unit circle because some of this stuff is going to simplify just beautifully. And actually, we don't have to visit our unit circle at all because I wrote things down off to the side like a smart lady. All right, what's the tangent of 60? Square root of 3. Tangent of 45 is a 1. All right, down in the denominator, you got a 1 plus, and then the square root of 3 times 1, which I'm not going to write down. So then I bet you're thinking, oh, wonderful, we're done. And then we have to remember there's some stupid rule of math that says you're not allowed to have a radical in the denominator. So we have to rationalize this expression, but it's not as simple as like multiplying top and bottom by the square root of 3. Your denominator is a binomial, which means you have to use what's called a conjugate. So the conjugate to 1 plus square root of 3 is a 1 minus square root of 3. We're going to multiply that by both the numerator and the denominator, and you just kind of have to trust in your math that it's going to work out. It will, and it won't be horrible, but we are going to take a few more lines of work. I'm just going to give you guys a heads up. We're skipping number 4 and 6, so if you find yourself running out of room, you can just scribble those out and work down the margin. So up here in the numerator, lots of foiling, guys. Square root of 3 times 1 is square root of 3. Square root of 3 times negative square root of 3 would be a negative 3, because it's like square root of 9. Inside arch here is negative 1. And then the last times last would be positive square root of 3. We'll come back to simplifying that in a moment. Now, when you multiply conjugates together, there should be quite a bit of cancellation. The outside and inside arches of the foiling should cancel. That's what a conjugate does. So 1 times 1 is 1. This cancels. I'm not going to write it down. And then negative 3. All right. Take a peek at that numerator. These guys, they're not canceling, but you do have 2 of them. So you got 2 square roots of 3, and then negative 3 minus 1, better known as minus 4, over negative 2. All right, PreCalc, we're home free. We just got to divide everything here by a negative 2. Now, because I got like deep-seated issues with simplification from previous teachers who were very picky about how I simplified, I always put the non-radical term first, so I'm going to write this positive 2 first, and then I'm going to write minus square root of 3. If you wrote negative square root of 3 plus 2, you're not wrong. It's just, I'm a little stuck in my ways, I guess. We divided the coefficients both by negative 2. That's tangent. So that was the easy way. Can you imagine what the not easy way looked like? It was bad. It was awful, in fact. All right. So we're going to move on down. I think those are actually okay. Let's go look right here. So you get into a bit of trouble when there's a radian measure, because, like, I don't know about you, but I'm not good enough at fractions to be like, oh, yes, 11 pi over 12 is clearly pi over 4 plus 2 pi over 3. Like, no, I'm not going to remember that. I'm not even think about that. So what we're going to do is we're going to convert it to degrees. And then you could go back and convert them to radians, but we're going to substitute in values from the unit circle. So, like, does it matter if I go back to radians? Like, not really. So once I knew this was equivalent to 165 degrees, we could break that up using 45 and 120. That would be 45 plus 120. Now, order, whose A and B, does not matter. So I know you're panicked, like, oh, what if I did 120 plus 45? It's fine. It'll work out mathematically the same. So what I'm seeing, and I'm going to leave it in degrees. Tangent, hello. Not that. We have cosine. So we have cosine, cosine, sine, sine. So cosine of 45 times cosine of 120. Cosine needs to use the opposite sign. So we're going to have a subtraction. And then sine of 45 times sine of 120. All right, here goes. Cosine 45, that's a nice one, right? Square root of 2 over 2. Cosine of 120. I always forget that one. Negative 1/2. Cool. Minus, and then this sine at 45 is square root of 2 over 2. And then sine of 120 would be positive square root of 3 over 2. So what you have now are a couple of radical things that we're going to smush together. This is the negative square root of 2 over 4 for a denominator. And then here, this guy smushed together is square root of 6 over 4. And they do have common denominators. There's not really anything you can do to make this prettier, guys. So just, I feel like I dropped a sign somewhere. Are we good? Negative square root of 2 minus square root of 6 over 4. Beautiful. Right off the tip of my tongue. I was going to guess that. Not. So that was fun. Now, the next few questions, this is kind of what we did on that warm-up sheet where you had to recognize which pattern it was and then simplify it. So we're going to skip those so we can look at the back. Everyone flip to the back, please, and look at number 9. There's going to be some questions on your homework and eventually on your test where I give you an identity to verify. And this is a question I saw from a few of you where we had a big conceptual mistake. If we're verifying this identity, you do not manipulate both sides. You can only manipulate one side, and the other side, technically you guys are supposed to be writing it all the way down your work like this. I don't make you do that, but if you found yourself to be manipulating both sides by accident, maybe start doing that on an identity. All right, y'all. Knowing what we know now about the sum of difference formulas, sine of pi minus x. Is there another way, a trade that you can come up with for sine of pi minus x? Yes, and it's called the difference sine formula. All right, so sine goes sine, cosine, cosine, sine with the same sign in the middle. Here goes. So sine, cosine, keep the minus sign. Sine, cosine, cosine, sine. So remember, we're working only with the left-hand side. We think about what we're looking at. Sine at pi. Isn't that somebody you know? Yes. What is the sine at pi? 0. So this is really 0 times cosine. This is just a 0. Minus cosine at pi. You know that. That's negative 1. Which makes it positive. Yep, it does, yes. So this minus minus thing ends up being positive sign. We'd be done. Sine x equals sine x. So neat. We can use these new identities to trade out. We're going to skip 10. We can also use these identities to solve. Okay, what we're about to do is a pretty nasty question. Just has a lot of manipulation. And the end result is it becomes what we're now going to refer to as an easy equation at the end. You guys are going to like wish for yesterday's problems at the end of this one. Okay? So we're trying to get it to look like one of yesterday's problems is what we're doing. Yow. I don't know. Cosine of something minus something. That's one of our new friends, isn't it? This is cosine, cosine, sine, sine. All right, here goes. That is cosine pi over 4 times cosine of x. Now cosine is the weird one. You got to switch the sign. So plus sine. So cosine, cosine, sine, sine. Here goes. Sine at pi over 4. Sine x. Don't do any unit circle fun yet. We got to keep going because there's a big subtraction sign in your problem. We can skip 12. Now, be careful, guys, because as the math teacher, I'm seeing we're going to subtract a whole bunch of stuff now, and most people are going to forget. So I'm going to put a big parenthesis set like that. And don't forget there's the rest of the equation on the other side. All right, this time you have a sine subtraction problem. If I was to expand that out using the identity we just learned for sine, he goes sine, cosine, cosine, sine. And he uses the same sign. I wrote too big, so I need to scooch. Sine, cosine, cosine, sine. So I'm sure you found out by now that this is very cumbersome to have to go back to the formula sheet over and over and over again. So at the end of our class, we're going to chant the formulas together off camera because no one needs to hear that. All right, here goes. There's some things we can trade out, and we also have this -1 that we need to distribute. So you need to make a note to yourself that this and this are going to get a negative distributed to them. I know you're running out of room, so I'm trying to simplify your life a little bit by not making you write down every single line. So the things that we need to visit on the unit circle are things with radian measures that we can actually look at. So for instance, all these pi over 4 measurements, we got these. What's the cosine at pi over 4? Yeah, so this says square root of 2 over 2 times the cosine of x. And then the sine at pi over 4, also square root of 2 over 2. Now watch your negatives here, guys. This next term is a subtraction. And then you got the sine at pi over 4, again is square root of 2 over 2 times the cosine of x. What about this next term? Negative, negative. That is a positive. Square root of 2 over 2 times sine x. And don't forget, this is an equation. It says equals -1. So, I know they're gross. This is welcome to trig, right? Things are gross in trig. Each term, you got to think about simplifying it. For instance, I'm seeing square root of 2 over 2 cosine, and then later on in the same side of the equation, a minus square root of 2 over 2 cosine. What happens there? They cancel. And then I'm seeing square root of 2 over 2 sine plus another square root of 2 over 2 sine. So you have 2 square roots of 2 over 2 sine. Guys, what does that mean?
Square root of 2.
Yes. So this is the square root of 2 sine x equals -1. Looky there. Now we got an equation that belongs on yesterday's test. I need you to solve, which means in this case you have to isolate the sine function. You're going to divide both sides by the square root of 2. And now I'm looking for sine x equals, I would never write it as -1 over square root of 2 because my unit circle doesn't look like that. They rationalize it. So tell me all the places where you get a sign of negative square roots of 2 over 2. And, nah, that's positive. There we go. So that was a hoot. So we had to use this new identity to essentially, it looked not simplified at first. It looked like we made it worse, but in doing that identity, we were able to simplify and swap out terms from the unit circle. Then we were allowed to collect like terms, and then we got what now I'm going to refer to as an easy equation. Yeah. All right. So I promised you I'd skip 12. Oh, apparently I was going to skip it anyways. Good thought, Taylor. Let's take a look at number 13. We've got tangent, blah, plus another tangent, blah. You notice anything about this equation? It's like the same thing. So like if you had 2x, if you had x plus x, what would you call that? 2x. So this is tangent plus tangent. Let's call it 2 tangent. Are you okay with that? So I'm still taking some algebraic liberties because, you know, algebra doesn't die, guys. The algebra rules still apply here. Think of this like an equation. Make your life easier. Do you see a coefficient of 2? So we divide by it? Probably. Get it out of there. So now I see tangent of pi minus x equals -1. At this point, if I wasn't paying attention to the lesson today, I'd be a little stuck. But this, I can trade this for somebody. All right, go visit your formula sheet. Tangent starts off using the same sign, and then the denominator switches signs on you. So for this guy, it would be the tangent of pi minus the tangent of x over 1 plus the tangent of pi times the tangent of x. Now don't forget, this is an equation. It says equals -1 on the other side. All right, time to go visit your unit circle. Tangent at pi. Don't get this wrong, otherwise we're going to have a lot of wrong things on the problem. Tangent at pi is 0, isn't it? Tangent of x is a thing, an algebra thing, leave it alone. And then this guy right here, again, will be a 0. So think about what's going on here, guys. 0 minus tangent. Well, I'm not going to write that. I'm just going to write minus tangent of x over, this is 1 plus nothing. Well, that's a 1, so I was kind of stupid. I didn't even have to write that down. Now I see I have a coefficient of -1, so let's hit everything by a -1 or divide by a -1. Y'all, we got tangent of x equals 1, positive 1. 2 places on the unit circle where you would get a tangent of exactly 1. So I'm looking for sine and cosine to be twin. Pi over 4. That would be a tangent of 1, right? And 5 pi over 4. You follow me, Daniel?
Yeah.
I noticed you haven't been taking notes today. That was a bad choice. Don't look for them for support. They agree with me.
No, I'm not looking for support.
Okay.
The reason I was like, what? Is because the only thing that I get confused on is just the simple, like,
Sine and cosine backwards.
This, I honestly, like, this doesn't bother me like this.
Ordered pairs are sine, comma? No, they're not. Hello. The ordered pairs are cosine, comma, sine.
Yeah.
That would have been confusing.
For some reason today I'm just having a lot of trouble with the unit circle.
I sensed that. All right, so tangent is sine divided by cosine, right?
Right.
So the pi over 4 family is where the tangents come out to 1 and positive 1 and -1. Because you would end up taking square root of 2 over 2 divided by square root of 2 over 2, which would reduce to 1. Okay? All right. I'm not a fan of tangents either, so I sympathize. All right, let's try another. One more, and then we'll chant. Whoo! Look at this. So, it looks a lot like number 11. Let's see what we can do. You've got sine of something plus something. So when I'm expanding sine out, the chant that we're going to practice in a minute is sine, cosine, cosine, sine. So that goes sine of the first guy, cosine of the second guy, keep the sine, plus sine, cosine, cosine, sine. There's a plus sign in between these terms. And now we've got a very similar looking thing, except it's sine of a minus b this time. So the only thing that's going to change in your setup here is that it's going to have a subtraction sign in the middle. So sine of x times the cosine at pi over 3 minus cosine of x times the sine at pi over 3. You can't read that, but that says sine. And then don't forget this is an equation. I get this from kids every year. They just like stop writing and then they're really confused later on. It says equals 1. Don't lose that. Okay, so I'm hearing there's some cancellation. So right here we got a minus cosine x sine pi over 3, and right here we got a positive cosine x sine pi over 3. And yes, those cancel each other. I didn't even bother going to the unit circle with those because you saw the algebraic term canceling. Had you substituted stuff in, you still would have saw them canceling, so don't fret. Let's talk about pi over 3 though. Oh, you want to simplify? I like that. Apparently I'm getting messages from something. All right, so these guys added together. Taylor says, take a little algebra step, guys. Call it 2 of those. I think that's brilliant. Now tell me what's the cosine at pi over 3. That's where we're all at on a Friday. Hello. You got a unit circle. 1/2. So you got 2 times the sine of x times a 1/2. Well, that will work out nice. What's going to happen here?
Divide by 2.
Don't they cancel? The 1/2 and the 2?
Yeah.
So y'all just got sine of x equals 1. Now, what you were thinking about doing, it still would have worked out. Tell me, where is sine 1? One place, please. Pi over 2. That was a hoot. All right, so you do have a homework assignment on this, and it involves all the parts of our lesson today. So it's going to start with questions where are they at? Back here where you got to break them up. There is, I believe, one where it's radian measure. So my suggestion is convert it to degrees and then just break up the degrees. Y'all caught my warning about, if at all possible, don't even talk about the tangent of 30 if you can avoid it. Please avoid it. You're going to have some questions where, just like our warm-up questions, where you had to recognize what pattern it is and then condense it using the identity, and then you're able to evaluate off the unit circle. Those are beautiful. You're going to have a question or two where you verify the identity based on this new identity, so that's kind of neat. And then you're going to have some equations at the end of your lesson, which are kind of the culmination of like everything we did in the lesson. So obviously those are the harder ones because it requires some old knowledge as well. All right, so lesson's ending. We're going to be chanting.